In this problem, they are asking you to identify what is the resultant of the force. If I draw a free body diagram, there is a force which is acting towards this direction and another force which is acting towards this direction. So only two forces. As per steps, first we will write down what are the coordinate points. Point A is at 3, 0, 4 meters. Point B is 2, 2, 0. Point C is 5, 2, -1. If I consider the free body diagram, you have point A, you have two forces FAB and another force FAC. Our first step is to identify what are these values of FAB and FAC. To solve this, we are going to do parallelly. We are going to identify what is our FAB and FAC. Let me identify what is FAB on this side, FAC on this side. To identify FAB, first I want to identify what is my position vector RAB. RAB is B coordinate minus A coordinate. So B coordinate is 2, 2 minus 3 minus 1 I vector, 2 minus 0 plus 2 J vector, 0 minus 4 minus 4 K vector. Similarly, let us identify what is our position vector for RAC. So RAC is C coordinate minus A coordinate. 5 minus 3, 2 I vector, 2 minus 0, 2 J vector, minus 1 minus 4 minus 5 K vector. The next step is we are going to identify what is modulus of RAB. So modulus of RAB is of 1 square plus 2 square plus 4 square. Similarly, here also it is RAC. Modulus of RAC will be root of 2 square plus 2 square plus 5 square. So to do this, we will use a shortcut in your calculator. I am going to consider this as a variable A, this as B, and this as C. Only I am going to change the input of these things and we are going to solve it. Let us proceed. Let us type this in our calculator as a variable. So root alpha A square plus alpha B square plus alpha C square. So now I am going to input what are the values of this A, B and C. Let us proceed with RAB. Press calc. A will be 1, B is 2 and C is 4. So it is showing as root 21. By pressing this, we are getting 4.583. So the value here is 4.583. Similarly, let us press calc again. Let us substitute the values with respect to that. A is now 2. This is for RAC. B is 2. C is 5. So root 33, by pressing this, 5.745. The value is 5.745. Next, we are going to identify what is lambda AB. So lambda AB is equal to RAB divided by modulus of RAB. Again, to identify this lambda AB, we can use two terms as an equation and we will identify one by one. I am going to consider alpha A divided by 4.583. this as a equation. So press calc. First a is -1. I'll type it as -1. We are getting minus 0.218. So minus 0.218 I vector. Press calc. Now a is 2. 0.436 j vector plus 0.436 j vector. Next press calc again or press equal to. Now your a is -4 minus 0.873 k vector minus 0.873 k vector. So next is I'm going to identify force AB with respect to this. Force AB is tension AB into lambda AB. So tension AB, according to the question, tension AB is given as 250 Newton. So I have to multiply the values with respect to 250. 250 into lambda AB. Let us identify what is FAB. 250 into 0.218. So 54.5 minus 54.5 I vector plus, so I am going to change only this 250 into 0.436 109 j vector. Again I am going to change this to 0.873 218.25 k vector. We'll call this as equation number 1. Let us do the same for FAC. Let us identify lambda AC. 2 divided by 5.745, which is 0.348. So lambda AC will be 0.348 I vector. Again it is same, plus 0.348 j vector. Now 5 divided by 5.745. We are getting 0.87 k vector minus 0.87 k vector. Now let us identify what is our force AC. So force AC is tension in AC into lambda AC. So tension in AC, we know that according to the problem it is mentioned as 450 Newton. So tension in AC is 450. So 450 into lambda AC. So let us identify what is our force. 0.348 into 450. We are getting 156.6. So 156.6 I vector plus 156.6 j vector, and let us identify for the last one 0.87 into 450. So we are getting 391.5. So minus 391.5 k vector. So now we have to identify what is the resultant of these two forces. So the resultant of these forces R vector will be summation of FAB plus FAC. In that case, I have to identify, I am going to add I components of these two, J components of these two, and K components of these two. So let us add the values and we will write it in terms of R vector. Minus 54.5, which is I vector, plus 156.6. So totally we are getting 102. So 102.1 I vector Next, both are addition. 109 plus 156.6. Totally, we are getting 265.6. So plus 265.6 j vector, and again both are negative here, which is also an additional value, so we will add both. So 218.25 plus 391.5, so we are getting 609 minus 609.7 k vector. So this is our answer. So the next thing is, they are also asking you to identify whether the friends is able to pull him out of this hill. To do that, we are going to identify what is the resultant modulus of this resultant. So to identify modulus of this resultant, so that is nothing but root of 102 square plus 265.6 square plus 609.7 square. So let's take root. So root of 102.1 square plus 265.6 square plus 609.1 square. So we are getting 672.28. So the total value is 672.28 Newton. This is the resultant of the two friends. So in which the force is acting. The force of climber is 700 Newton, whereas the resultant force is 672.28 Newton. The force 672 is less than the weight of the climber. Since the resultant force is less than the weight of the climber, the friends will not succeed to climb him out. So this is my final answer. Thank you.